Hey, only one at a time. He raises both hands as glowing data lines pause. I'm I2C. And I keep communication organized. You see these two glowing lines? S-D-A. S-C-L. That's all I need. Two wires. That's it. Clock line. Data line. Simple. Efficient. Powerful. Multiple devices can connect to the same two wires. Temperature sensor, display module, EEPROM, or TC clock, all sharing the same bus. But chaos would happen if everyone talked at once. That's where I step in. One device becomes the master, usually the microcontroller. It controls the clock. And when it wants to talk, it calls a device by its address. Each device has a unique address, like a name tag. The master says, "Hey, device 0x3C, are you there?" And only that device responds. Everyone else stays silent. Data travels bit by bit, synchronized with the clock pulses, orderly, structured, predictable. I coordinate start conditions, stop conditions, acknowledgement bits, no guessing, no shouting over each other, just controlled communication. And because I only need two wires, I reduce complexity, fewer traces on the PCB, simpler wiring, cleaner designs. Embedded systems love me. Small sensors, compact devices, expandable systems. But remember, I'm not about speed, I'm about simplicity and coordination. There are faster protocols, but none as elegant for small device network. I stretch my tiny arms and devices line up. I stomp my little foot and data flows in rhythm. Two wires, many devices, perfect coordination. I'm I2C, the organized voice of embedded communication. I send out a start condition, and then I call out the address of the device I want to hear from or send data to. Let's say I want to talk to sensor 0x27. I send out its address, and if sensor 0x27 is ready, it sends back an ACK, an acknowledgement saying, "I'm here and I'm listening." Then the data packets, these glowing bits of information, start zipping along the SDA line, synchronized perfectly by the SCL clock pulses I provide. Every 8 bits of data get an ACK to confirm they arrived safely. It's like a digital handshake after every sentence. When we're done, I send a stop condition and the bus is free for the next conversation. It's efficient, it's coordinated, and it's how so many amazing electronics, from your phone to your smart home gadgets, stay connected. So next time you see your devices working in harmony, remember the little I2C controller, making sure everyone gets a turn to speak on our amazing two-wire highway.